Hello, welcome again. We are solving IDJ physics. The topic is dual nature of radiation and matter. Question number 8 is when a wavelength of radiation falling on a metal is changed from 500 nanometer to 200 nanometers, the maximum kinetic energy of the photoelectron becomes 3 times larger. The work function of the metal is close to option 1 0.61 electron volt, option 2 0.52 electron volt, option 3 0.81 electron volt, option 4 1.02 electron volt. So we know that the maximum kinetic energy is E minus pi naught, where E is your total energy of photon and pi naught is your work function. Okay, and this E is given by h into frequency, and frequency is c by lambda. Okay, and according to the given condition, the maximum kinetic energy of the photoelectron becomes 3 times larger when the wavelength is changed from 500 to 300 nanometer. Okay, so when the wavelength is 200 and when the wavelength is 500, the duration of kinetic energy is 3. Okay, so k max 2 by k max 1 is 3. Okay, so this will be your 3 into sc 500 minus 502 minus 9 minus 3 pi naught, and sc 200 minus 9 into minus pi naught. Okay, so this is your if you multiply it by 3, and then it will be like this. Okay, and we can take sc as common, so it will be 3 by 5 minus 1 by 2 into 1 by 100 into 10 minus 9 sc. Okay, and this will be a 2 pi naught, and pi naught will be your 6 point and because value of h is 6.624 into 10 minus 34, and value of c is your 3 into 8, and this will be divided by 1000 because this is your 10. Okay, this is your 10, and because 6 minus 5 is 1. Okay, this is your 1 by 10. Okay, so this will be 1000 times by 9 into 2. So in terms of this is the work function in joule, and in terms of electron volt, we'll divide it by 1.602 into 10 minus 19. So answer is your 0.61 electron volt, or it will be putting the value, solving it. Okay, so this will be approximately 4, and 4 into 3 is your 12, and 12 divided by 2 is your 0.6, or then we can add and subtract according to the sign, the rate power of 10. Okay, so answer will be 0.61 electron volt. Option 1 is the right answer. Next, a particle is moving 5 times as fast as an electron. The ratio of the Broglie wavelength of particle to that of electron is 1.878 into 10 to the minus 4. The mass of the particle is close to option 1 4.8 into 10 to the minus 27 kg, option 2 1.2 into 10 to the minus 28 kg, option 3 9.1 into 10 to the minus 31 kg, and option 4 9.7 into 10 to the minus 28 kg. Now the de Broglie wavelength is lambda is equal to h by mv, and lambda is your de Broglie wavelength, and h is your 6.626 into 10 minus 34 joule second. This is your momentum, where v is velocity and m is mass. Okay, now when we consider the particle, when we consider a particle, then we will take mp and vp, and the wavelength will be your lambda p. Okay, and value of h is 6.626. When we consider electron, we will take mass of electron and velocity of electron, so this will be your lambda e. Okay, now lambda p by lambda e will be equal to me mev by mpvp, and vp by ve is your pi. Velocity of particle by velocity of electron will be your pi. Okay, and that is given. The particle will be 5 times fast as electron, and so Vp by Vb is your 5, and the ratio of lambda is your 1.878 into 10 to minus 4, 1.878 10 to minus 4. Okay, and this is your mm, this is mass of electron is your 9.81 per minus 31, so Me will be your 9.1 10 to minus 31, and Vp by Ep is your 5, so it is 5, and this is your Mp, so Mp is your 9.72 10 to minus 28 kg. So option 4 is the right answer, 9.7 10 to minus 28 kg. Option 4 is the right answer. Okay. Next, when radiation of wavelength lambda is used to illuminate a metallic surface, the stopping potential is V. When the same surface is illuminated with a radiation of wavelength 3 lambda, the stopping potential is V by 4. If the threshold wavelength of the for the metal surface is n lambda, then the value of n is. So this is the graph between the stopping potential and 1 by lambda. So when lambda is wavelength, and this is following the straight line equation. Okay, when velocity potential is v, sorry, stopping potential is v, and then the wavelength is lambda. Okay, so this is a straight line, and the equation of straight line is y is equal to mx plus c. When x is 1 by lambda, okay, and y is v, because when wavelength is lambda, potential is v, so it will be v m by lambda plus c. And for x 1 by 3 lambda, for x when the wavelength is your 3 lambda, and the stopping potential is v4, v by 4. Okay, so it is v by 4 is equal to m by 3 lambda plus c. Okay, so this is equation number 2. Okay, now solving this, we have 3 v by 4 and 2m 3 minus 1, 2m by 3 lambda. So m is your 9v lambda by 8. Okay, so slope is your 9v lambda by 8. Okay, and findings, now we have found out one constant, that is m, and other constant can be found out by putting the values. So v will be your 9v lambda by 8 into putting the value of m into 1 by lambda plus c, and lambda will cancel out, and so it will be 9v by 8 minus v will be equal to c, or it will be minus v by 8. Okay, sorry, 1 v minus 9 by 8 v. Okay, so this is your c is your minus v by 8, and the general equation is y is equal to 9v lambda by 8 x minus y v by 8. So the equation is now we have put the value of m and c. So the equation is this: for threshold wavelength the stopping potential should be 0, and if we put y is equal to 0, then we can find out x. Okay, and then it will be then x is your and when threshold potential is 0, then the wavelength is n lambda. Okay, so putting x is equal to 1 by n lambda, and then we can find out value of n as 9. Okay, just putting the value. Here we will put 1 by n lambda, lambda will cancel out. Okay.